everyone. Uh, Today we're going to talk about building a cloud-native software as a service for CERN's 1,000 Drupal sites. So I am Rajula. I have my colleagues here, Francisco and Constantinos, with me. So we'll start with the question: what is CERN? So we're the world's largest particle physics laboratory in the world. But do we do just physics? Actually, no. So this is also a place where the information technology space has taken big leaps, such as the invention of the World Wide Web and also the development of grid computing. So what has Drupal got to do with CERN? So we are on 1,000+ websites running on Drupal. So we'll start with the Drupal use case at CERN. So at CERN, we have a different set of audience and users. So we have different kinds of site builders. We have physicists, administrators, Drupal experts, and comms experts. And we have different visitors for all our websites. So we have general public, we have authorities, the member states, and the CERN community as well. So this is a screenshot from our presentation from DrupalCon 2011, where we had 100 websites. And today we have 1,000 websites. So we have scaled 10x in about 10 years. So we'll talk about the first implementation of a Drupal infrastructure that has been existing till now. So this is how it was. So we hosted everything on virtual machines. All websites have shared PHP FPM processes. They all the sites shared a common NAS. The core modules code was also shared across all websites, leaving very small space for customization. And we had no composer access to the end users. So what did we want? So we wanted a lot of things. So we wanted to create our own Drupal distribution with our own custom CERN themes and CERN modules built in, and our own scripts that would make it easy for us for operations. And we wanted isolation between all the websites. And we wanted better resource management. We wanted more resources for sites that have more traffic, like the home.cern website. And we wanted more flexibility for users with very less knowledge on the infrastructure. And we wanted to reuse infrastructure components. So there are other web services at CERN, and we wanted to reuse infrastructure across these services. And we wanted reliable hosting. We wanted more easy to scale up and scale down. And we wanted to make it easy for users to have their own custom modules and themes. And we also wanted to make it easy to do automatic upgrades and failure recoveries when there's a new update or new versions. So what did we end up doing? So our plan was to move to a cloud native infrastructure. So just reiterating, everything was on monolithic, like we explained. We wanted to move to a microservice architecture where there's a lot of isolation. So the new infrastructure is based on Kubernetes, but we use OKD. OKD is an open source community version of a Kubernetes distribution. The it's an OpenShift, but it's a community version of OpenShift. So I'll now let my colleague Francisco to talk about the components.
Hello. So first of all, we're going to talk about the CERN Drupal distribution. This is one of the core modules of our new infrastructure. So our Drupal distribution is overall not that different from any common Drupal distribution. We have Composer, we have our own modules, we have our own themes, and we have our own images. But I want to focus on the images. So what do we have special on our images that it is not commonly used? First of all, we have source to image. Source to image allows users to create their own images based on our base image, and we can easily deploy it to our own infrastructure without losing any of our features and allowing users to have their customization. Second, we have our own CI/CD, which starts with us. We integrate with the Git, we create new features, new changes to the repository. Whenever this repository changes go to the master branch, a new pipeline is released. This pipeline will create a new image that everyone can use. That image will go to our container registry. And when it reaches the container registry, the Drupal site operator will be notified that a new version is available, and it will deploy it into Kubernetes. So talking about Drupal site operator, we first need to understand what is an operator. So I don't know how many of you are familiar with operators, but operator is basically like a cook. It gets a recipe, and it reads the recipe and tries to convert that recipe into a Drupal site in the new infrastructure. Let's see an example on how a recipe looks. So here we have a simple recipe on a website. We can see from the recipe that a name has been given, and also we have some specifications. We have defined the site URL, we have defined the version, and if we want, we can set a specific configuration based on the Drupal site needs. With this operator, we also have other operators. They take care of other resources that might be required by the Drupal site operator. As an example, we have the authorization operator. They take care of the single sign-on component. We have the database operator that takes care of the database, the Ceph provider that takes care of the file system, and the network operator. And altogether, these operators allow us to have the Drupal site running like it was running in the old infrastructure, but now with some extra capabilities. So the question is, where are we at now? So currently, we are in the process of migration. So I'm going to show you how we are currently migrating from the old VM-style infrastructure to the cloud-native infrastructure. First of all, we create a new project in the new infrastructure. In this project, we use our CERN Drupal distribution that has been created, but we create a blank website. Then we copy into this blank website the files from the old website. We also copy a database dump. And at the same time, we convert the old single sign-on rules into the new ones. After copying the files and the database dump, we upload the database into the new infrastructure. And then we do some drush commands that allow the website to look exactly like it was previously. So finally, what we conclude from our migration. So let's look into the two looks. The first, the infrastructure side only, Kubernetes. Thanks to Kubernetes, we reached something that we didn't have in the virtual machine infrastructure, which was isolation. So previously, the file system was shared among all websites, while now each website has its own file system. The same thing for resource management. Right now, we can properly manage each website resources and scale according to their needs. We also have reliable hosting. So due to the Kubernetes infrastructure, as you probably know, now we can probably deploy more pods if required, change our deployment based again on our needs. We can also reuse infrastructure components. So one thing that we had previously was that our infrastructure was unique and it didn't share anything in common with any other infrastructure at CERN. Currently, our infrastructure has the same based Kubernetes distribution, and we basically put on top our custom operator that will try to answer the Drupal site needs. And finally, we have automatic upgrades and failed recovery, something that is common given the infrastructure sharing. On the other side, we have our CERN Drupal distributions. So on the CERN Drupal distribution, we now allow custom modules and themes for users. We also give them more flexibility. Again, thanks to the isolation of the infrastructure, now users can access the file system with more permissions because they will not compromise other users' files. And finally, thanks to the CI/CD, we also have automatic upgrades and fail recovery. Finally, we would like to point out that our code is Apache licensed, it's open source, and you might see it if you want after this presentation. So we would like to thank you for seeing our brief explanation on how we change from VM infrastructure to a cloud-based infrastructure. And we also invite you to see our next presentation tomorrow on the community perspective of our Drupal infrastructure. Thank you. And now we're going to take questions.